To dive into the last section of chapter 7. 7.5. And we are going to be solving rational equations. Y'all got calculators, right? Don't need a graphing calculator, but you need a calculator. Alicia. So, when we get into solving rational equations, as I have mentioned multiple times, the hardest thing about this chapter is knowing what to do when you multiply versus when you add versus when you subtract versus when you divide versus when you solve. Why is it impossible to solve everything that looks like this that was on our homework yesterday? Doesn't have an equal sign. So please pay close attention to if there is an equal sign involved. Because when there is an equal sign involved, that's when we are solving. And much like other parts of this chapter, you have all the necessary skills to solve rational equations. You've done it before. Now this is one version of a rational equation. This version of a rational equation you saw last year in geometry. It's known as a proportion, when you have a single fraction equal to a single fraction. There are a couple of different ways to solve rational equations. One way is to get them to become a proportion. Because proportions solve using what? Cross multiplication. Remember multiplying those? When they have pluses or minuses, what do you need? Parentheses. 2x plus 3 is going to get multiplied by 3x plus 21. And that is going to be equal to 5 getting multiplied by x plus 7. Where do I start solving? Distribute. 2x times 3x. 6x squared. 2x times 21. Positive 42x. 3 times 3x. Positive 9x. 3 times 21. 63 equals 5 times x. 5x. 5 times 7. 35. My rational equation turned into a quadratic equation. To solve quadratics, you want them equal to 0. So I need to combine like terms and get it equal to 0. So I'm going to start by just combining the like terms first. And then I'll move things across. And I will get 6x squared plus 46x plus 28. Yes, no, maybe. Did I math? Got one head nod. Equals 0. What are options for solving quadratic equations? Quadratic formula or factoring. I personally prefer factoring. Greatest common factor?
6.
No. 2. Left with 3x squared plus 23x plus 14 equals 0. It's just a change in the wind. Can I continue to factor? Can I do AC method?
Yes.
3 times 14 off to the side. It's 42. Two things that multiply to 42 but add to 23. 1 and 42. Nope. 2 and 21. Oh, that one works. X squared plus 2x plus 21x plus 14 equals 0. I'm going to ignore my GCF for a little bit. Out of the first group, I can factor out an x, leave me with 3x plus 2. Out of the second half, I can factor out a positive 7. Leaves me with a 3x plus 2. X plus 7. 3x plus 2. And the GCF comes back. When I'm solving the GCF, unless it's got a variable, doesn't do anything. Can I split it and set it equal to 0? Sure. Is it going to do anything? No. X is equal to negative 7. And x is equal to negative 2/3. Are we okay with me jumping to negative 2/3? I subtracted 2, I divided by 3. But those are not 100% the answer. And here's why. Rationals have something about them that quadratic equations do not have. Rationals have excluded values. What were the excluded values of my original expression? First denominator was x plus 7. Set it equal to 0. X was not allowed to be equal to negative 7. The second one, 3x plus 21 equal to 0, would have also given me x is not allowed to equal to negative 7. Do you see a bit of a conflict? X is not allowed to be equal to negative 7, but x is negative 7? It's what's known as an extraneous solution. When you are solving using any sort of opposite operations, you're ignoring the original domain of the original expressions. And when we moved from rational to quadratic, rationals have excluded values, have asymptotes in their graphs that prevent their domain from being all real numbers. Quadratics don't. And so it creates these extraneous solutions that really are solutions to the original equation, or to an equation, that don't work in the original. They're false answers. They're answers that don't work. And so with rationals, you have to check for excluded values when you are solving. You have to check that the answers you got are not excluded values. The only answer to this equation is actually x equals negative 2/3. This is one way to solve a rational equation. This way works nice if it's a proportion. Doesn't work so nicely if it's not a proportion, but it also can have issues of getting really, really, really big numbers. Because did you notice that it turned into a quadratic that, while we know how to factor it, is kind of a pain in the butt to have to do? Because it required AC method. And if you didn't want to factor, you could have done quadratic formula, but quadratic formula, while not bad, is also a little bit tedious. There's another way to solve. Do you notice it's the exact same equation from above? Yeah. Okay. I purposely did the same equation. Way 2 of solving. This way of solving tends to have simpler equations to solve, but it's not as intuitive. Cross multiplication is solving using opposite operations. It's recognizing I'm dividing by something and I don't want to, so I multiply by it. That's what cross multiplication is doing. So it tends to be more intuitive on where to go with it. This next way of solving is less intuitive. It's also more likely to get mixed up with addition. So I am going to show you both. You can make a decision upon which method you prefer, but if you prefer the second method, you must be careful to make sure you are only doing it when solving. You are not doing it when adding and subtracting fractions, as many people try to do. You cannot add and subtract fractions this way. People tend to mix it up because, hello. Yeah. Yep, bye. Counseling office. They said it's gonna be like 5 minutes, so. So, just be careful with this. Now, the reason it tends to get mixed up is because step 1 is to find the least common denominator of all fractions. I don't care if there's 2 fractions, 3 fractions, a dozen fractions. I'm not gonna give you a dozen. But you find the least common denominator, you look at all of the fractions. So, do you notice pluses and minuses in the denominators? Which means I need to factor them. Factor x plus 7. It's x plus 7. What do I do when it's got a plus but it doesn't factor? Put it in parentheses. 3x plus 21. Get factor out of 3. Leaves me with x plus 7. So, 2x plus 3 over x plus 7 is equal to 5 over 3 times x plus 7, least common denominator. Do you notice they have something in common? Yeah. X plus 7's in common. Do you notice they have something not in common? I need the thing they don't have in common. I also need just one of the items they do have in common. I don't need an x plus 7 twice. Step 2. multiply each term, each fraction, by the least common denominator. Now note, I did not say by top and bottom. I did not say by what they were missing from the least common denominator. This is where it mixes people up the most. Now when you multiply by a fraction, technically you're multiplying by something over 1 by the fraction, which means in all technicality it's only being multiplied by the top. And at this point, every single fraction should simplify. Specifically, it simplifies in a way where the denominators disappear. Because of the fact that the least common denominator is always going to carry everything from the denominators. Now, in this one on the left side, the x plus 7 is going to cancel out. The 3 is still existing. In the second one, the 3 and the x plus 7 cancel out. You are left with the 3 getting multiplied by the 2x plus 3, which is technically in parentheses, equal to, and on this side, 5. That equation looks significantly nicer than that equation. Solve it.
It's just spacing out. It's just spacing out.
Yeah. It's getting rid of denominators. 6x plus 9 equals 5. What? Yeah. There's many ways. Subtract 4. X equals negative 4 divided by 6. Simplify a fraction, and x is negative 2/3. Did we get the same answer as the previous problem? Yeah. Do you notice the extraneous solution didn't show up? This way doesn't always avoid extraneous solutions, but it avoids some of them. Same problem solved 2 ways. I personally prefer the second one, but again, you cannot mix it up with adding and subtracting. You got to be careful with that. Ready for another problem? You can solve it either way. If you are going to solve using the first method, you cannot cross multiply until you have a proportion, until you have a single fraction equal to a single fraction. Which means if you want to cross multiply to solve, the first thing you have to do is add those two fractions. To add fractions, what would you need? Common denominator. Least common denominator of those two fractions would be? It would be 5 times x minus 3. I'm going to solve both ways on this one. After that, I'm not going to solve both ways every single time, but I want to show you both ways. Way number 1, I would find the LCD of 5 and x minus 3. And what I would get my fractions to have said common denominator. What would I have to multiply by the first fraction? What's it missing? The 5. What would I multiply by the second fraction? The x minus 3 in parentheses. Five times 7 is 35. Denominator is now 5 and x minus 3. Plus 2x minus 6 over 5 times x minus 3. Still equal to 13/20. Once we get a common denominator, we add or subtract. In this case, it's add. 35 plus 2x minus 6 all over 5 times x minus 3 is equal to 13/20. And I combine like terms. 2x plus 29 over 5 times x minus 3. Now it's a proportion, which means now I can cross multiply. 20 gets multiplied by 2x plus 29. 13 gets multiplied by 5 and the 3, or x minus 3. $40x plus 580. Thank you. Equals 13 times 5 is 65. So 65x minus 195. Subtract the 40x, I get 15x. Add the 195. I get 775. Divide by 15 and x is, did I do that right? I'm not doing 13 times 3.
65 minus 40 is
25? Yeah, I knew I screwed up somewhere. That makes more sense. X is 31. So, is this doable? It should be. Is it tedious? Yes. You want to see option 2?
Yes.
Tape. Said I was going to do this problem twice. Way number 2. Find the least common denominator of all of the fractions. All of my fractions are x minus 3 and 5 and 20 for denominators. When finding the least common denominator, work with binomials and monomials separately. 5 and 20. Smallest thing they can multiply to become is a 20. If you're not sure about that, look for the greatest common divisor. They both divide by 5, and this is 5 times 4. In common, they have the 5, and I need a 5, as well as the 4. As well as the x minus 3. My least common denominator for all fractions is 20 times x minus 3. Where are we at the time? Okay. Step 2 is do what? Oops, that's not what I said. Multiply all of the terms by that least common denominator. So, I'm multiplying this first fraction by 20 and x minus 3, the second fraction by 20 and x minus 3, the third fraction by 20 and x minus 3. Simplify the fractions. What's going to cancel out of the first fraction? The x minus 3, that's the only thing in the denominator. The denominator cancels. Out of this one has to cancel out a 5. The 5 is going to cancel with the 20, leaving a 4. Divide, not subtract. Out of the third fraction, the 20 is going to cancel out completely. I am left with 7 times 20 plus, keep an eye on this sign, 2 times 4 times x minus 3 equal to 13 and x minus 3. Seven times 20, 140, plus 2 times 4 is 8, distribute, and I get 8x minus 24 equals, distribute, 13x minus 39. Combine like terms, 140 minus 24, 116, plus 8x is equal to 13x minus 39. Subtract the 8x, I get 5x. Add the 39. Get 155. And divide by 5. Guess what? X is 31 again. Which way do you prefer? Most people prefer way 2. Before we are done, check if it's extraneous. What are my excluded values in this problem? 3. This one gives me 3. That one gives me nothing. That one gives me nothing. Is 31 3? No. You're fine. But don't forget to check for extraneous. Okay, I got one more example. We are not going to do it both ways. You vote the second way?
Yeah.
I vote the second way too.
It's just more funded.
Sure. Actually, yes. Three x over x plus 2 minus 2x squared minus 8x minus 72 over x squared minus 4x minus 12 equal to 6 over x minus 6. Step 1, find the least common denominator of all the fractions. When you see pluses or minuses, what's that mean? Factor. Can I factor x plus 2? Parentheses. Can I factor x squared minus 4x minus 12? Yes. Full AC? Shortcut. Two things that multiply to negative 12, add to negative 6.
You mean 4 minus 6 and 2?
Negative 6, positive 2?
Yes.
3 and 4 multiply to 12, but they're not going to give me the negative 4. Lazy me says, this is now my denominator. X minus 6. Doesn't factor. Parentheses. Do you notice the denominators have some things in common? Got an x plus 2 between these two. And an x minus 6 from these two. I just need one of each. X minus 6, x plus 2 is my LCD of all of it. After I find the LCD, when solving, I do what again? Multiply it by all of them. It's always going to end up on top. X minus 6, x plus 2. X minus 6, x plus 2. I put these a little too close together. X minus 6, x plus 2. Just to do what? Cancel. Cancel denominators. X plus 2 is gone, so is that one. X minus 6 and x plus 2 are both gone. That's kind of a good thing because I don't want to multiply that by something. X minus 6, gone. I'm left with the 3x and the x minus 6 on the first fraction. Minus the entire binomial, which means it's in parentheses because I'm subtracting it. Equal to 6 and x plus 2. Distribute and solve. Make sure you distribute your negatives. Mine like terms. 3x squared minus 2x squared is x squared. Negative 18 plus 8x is negative 10x. Plus 72 equal to 6x plus 12. To solve a quadratic equation, it must be equal to 0. So I subtract the 6x and the 12. X squared minus 16x plus 60 is equal to 0. Shortcut, two things that multiply to 60 but add to negative 16. Negative 10 and negative 6. X equals 10 and x equals 6. Before I call either of them good, check what? That they're not extraneous. How do I check that they're not extraneous? I make sure that they aren't excluded values. I get an x plus 2 in the denominator. X is not allowed to be equal to negative 2. I get x plus or minus 6's in the denominator. X is not allowed to be equal to 6. Are either of them excluded? 6. X equal to 10 is the only solution. What can I do if I'm not 100% sure I'm right? Plug it back in and see if the equation works. I get asked all the time, I don't know if I'm right. Well, plug it back in and check. You got a calculator? It's not the prettiest equation to plug back into, but the calculator knows how to do PEMDAS. Just make sure you put parentheses around things with pluses and minuses.